All right, hello, my wonderful students. This is part 2 of foldable number 3. And for this one, we have another piecewise function with 3 functions in it. And we're going to go ahead and do the first one green. I think we did the next one blue. And do the last one purple. Okay. So our first function is actually, we're going to go ahead and do our domains for the restriction of domains. So the first restriction we have is on the zeros. If you notice, these share zeros, and then these share the 4. So we know our first restriction is here on the actual 0. So I'll put some little dotted red lines. So we know, that graph is going to go up to here and then go up to here. And then the next one's going to be at 4. Sorry for the shadow, but as soon as I move my hand, you guys will be able to see. Okay, and now we're going to go ahead and graph this one here. This is a parent function that is at 0, 0, starts here, and it is equal to, so the point at the origin is going to be used, so it is going to be solid, or closed circle, not open circle. And we can't go this way because it only works when x is less than 0, and less than 0 is this way, so we have 1, 1, 2, 4, and 3, 9, which is about up over here. So we're just going to go ahead and right over there. Okay. Bam. Then we're going to go to our blue function, which exists between 0 and 4, both less than. So both lines are going to have open circles, open-ended, because they don't include. So it can go up to 0 and it can go up to 4, but they can't actually include 4. This includes 0 and this includes 4. And this is just a constant at -2. So we'd go down to -2 here, put an open circle, -2 here, put an open circle, and it's just a straight line all the way across. And it's because this is like y is equal to -2, and y is always -2 on this line. Doesn't matter if you're at 1, still -2, at 2, still -2, 3, still -2, and 4 cannot be -2. That's a little trick, see? Because it's of the restrictions. All right, now we go to our purple one. Oops, sorry for moving it. Our purple graph is a absolute value function, and it's been moved over 4 units to the right, which is kind of perfect because that's where we are here. And we have x is greater than greater than or equal to, meaning that we will have a closed-ended graph on the actual asymptote right there, and we can go ahead and 1, 1. 1, 1, and then draw our nice ruler. I always try to do freehand and it never comes out nice. So nice little ruler, go up. And once again, I mean, in reality, the absolute value actually looks like this, has like a V, but the graph only exists when x is greater than 4, so we can't actually use that last part. All right, and this is when we fold this over to put our notes. We're actually going to call this a quadratic constant absolute value piecewise function.